Let's look at some of the units we use for measuring things. When we talk about length, we use millimeters or centimeters or kilometers, imperial measures such as inches, feet, miles, and so on. There are many, many more as well. We then have dimensions that we use for area, millimeters squared, centimeters squared, imperial measures again of feet squared, miles squared. We also have area measures such as acres, which is an old imperial measure, and hectares, which is a number of meters squared. And then we have measures of volume, and this is millimeters cubed, kilometers cubed. We also have measures that are just for volume, such as litres and decilitres, and gallons and pints, and so on. We're going to concentrate on this video on the kinds of measures we've listed above, and we want to ask ourselves a question: why are they like this? Why are they millimeters and millimeters squared and millimeters cubed? Let's have a look at an area. To work out this area, we do the length times the width, which is 4 centimeters times 3 centimeters. Let's rearrange that. We get 4 times 3 times centimeters, and if you think about it, that's 4 times 3 is 12, and centimeters times centimeters is centimeters squared. It's the index of 2 on the centimeters that tells us that this is an area value that we're dealing with. We can look at the same kind of example for volume. Here's a cuboid. The volume of a cuboid is the length times the width times the depth. So in this case, we have 2 centimeters times 3 centimeters times 4 centimeters, which is 2 times 3 times 4 times centimeters times centimeters times centimeters, and that gives us 24 centimeters cubed. Again, it's the cubed index on the centimeters that tells us that this is a volume value. So basically, you should be able to tell just by looking at the units whether a measure is a length, an area, or a volume, by seeing if there's no index, or whether there's an index of 2, or whether there's an index of 3 on the units. Let's make this a little bit more complicated by looking at mixed dimensions. As an example, we're going to look at the formula for working out the speed of something. And the formula for working out the speed is the distance travelled divided by the time taken. So just looking at the units here and using metric units rather than imperial, we have speed is equal to meters divided by seconds. Now this can be written as meters divided by seconds, the way we have done there, or with a backslash, the way we have done there, or as meters s to the minus 1. This, you should recall, is one of the index rules. 1 over s is the same as s to the minus 1, in the same as 1 over s squared is s to the minus 2, and so on. There's a video on this in the number section under the powers and brackets topic. Either way that you write it down, we usually say this as meters per second. Usually the negative index indicates per something, in this case meters per second. Let's look at some more complicated examples. First one we're going to look at is density. This is the measure of mass or weight per unit volume. Can be per unit area, but in this case we're looking at per unit volume. So density is kilograms per cubic meter. So we write it as kg m to the minus 3. The m to the minus 3 meaning per cubic meter, because that's 1 over meters cubed, and the kilograms is obviously the weight of the object. So kilograms per cubic meter. Here's an example of how we work with this. Let's say we have a block of wood that's 50 centimeters by 50 centimeters by 20 centimeters, and it weighs 2 kilograms. What is its density in kilograms per meter cubed? Okay, the first problem you've got there is that you've given the measurements in centimeters, but you're asked for the density in per meters cubed. So the first thing to do is to convert from 50 centimeters and 20 centimeters to 0.5 and 0.2 meters. Then you can use those revised values to work out the volume, which is 0.5 times 0.5 times 0.2, which equals 0.05 meters cubed. Now density is equal to the weight divided by the volume. Now you either know that, or you can actually work it out from the units, because we've got a mass unit, the kilograms, and we're dividing by a volume unit. So the density is the weight divided by the volume. So even if you didn't know what the density was, you could work it out by looking at the dimensions that you've been asked to give the answer in. So in this case that's 2 divided by 0.05, and that gives us a value of 40 kilograms per meter cubed. You have to ask yourself, does that sound about right? Well, a block of wood is quite big, particularly if it's a meter cubed, and then it's going to probably be quite heavy. So 40 kilograms is quite heavy. It's about half the weight of an adult male. Therefore, it's in the right ballpark, isn't it? So we've done a bit of a sense check on that answer as well. Let's look at another example, this time acceleration. Acceleration is the measure of how quickly things change velocity. So if you think of meters per second, this is the number of meters per second that things change, or meters seconds to the -2. So an example here is the acceleration due to gravity. The acceleration due to gravity is 9.81 meters per second squared. So if you were to drop an object from a tall building, every second that it falls, it would increase its speed by 9.81 meters per second. Finally, let's look at some examples of dimensions and see if we can work out what they actually are. So the first one is grams per centimeters cubed. Well, that's got a mass and a volume, so it must be a density. Then we have centimeters seconds to the -2. It has a distance and a time squared. Well, that's going to be an acceleration, isn't it? Then we have meters squared. Well, that's a distance squared, so it must be an area measure. And then finally there we have grams meters to the -2. That's a mass, and it's an area, so that's going to be a density. So I hope you can see there that mixed dimensions are actually fairly straightforward, as long as you remember what the index means and what the negative or positive number in the index means. With a little bit of practice, you'll be able to look at the dimensions that you're given and work out what kind of measure it is you're dealing with. And it will also help you to do the calculation that you're required to do by telling you whether you have to do a multiplication or a division.